Well, hello everybody.
Hello.
Can everybody hear me okay?
Yeah.
Well, I apologize, we don't have a sound system. As many times as we've done this show, I think next time we'll come up with a sound system. If at any time that my voice kind of gets quiet, please let me know and I'll speak up. I hope you enjoy the presentation. We kind of mixed things around a little bit. We've got so many different projects, it's hard to pick what's going to be interesting to talk about. Well, the big boy, of course. But on top of that, we also work on all kinds of other things in the shop. We generally don't physically work on the building, but sometimes we got to do what we got to do. A couple years ago, we took out the false ceiling in the shop so we could start upgrading the facility, eventually leading toward putting cranes in, and we're really close to doing that. So we're going to put a big overhead crane in what we call the erection bay, which is the largest part of that building. The whole idea started some years back, and for those of you that have seen this presentation or other presentations that we've given, we've talked about where the STEAM program is going and how we got where we are and where we want to be. And part of the where we want to be story involves the 4014. The Union Pacific and the railroad in general hasn't always wanted to restore anything, really. So we're lucky that in the year 2017, we have the opportunity to continue to run steam locomotives. It's just a special privilege for anyone who gets to work on historic equipment. Steam locomotives are fascinating for many of you. I recognize some in the audience that work on steam locomotives, are very familiar with them and how special they are to work around. When you get to work around the larger locomotives and have the opportunity to operate those machines on a vast railroad network, I mean, it just doesn't get any better than that. But we're very much like every other department on the railroad. We have our accountabilities and our deliverables, and those are making sure that the locomotives are available for service, that they're in the absolute best condition that we can make them, and we've got all the regulatory compliance that all other rail vehicles have to comply with. We have to comply with those too. So as we started to talk about the big boy, that question was posed to me back in 2012, and I'll never forget that moment. I didn't think I was in trouble, but I got summoned upstairs to the top floor of the headquarters building in Omaha. And at that time, my boss was a senior vice president, and he asked me, just a little bit of small talk, but he got right to the point, would you be interested in restoring a big boy? And then he immediately followed it was, could we restore a big boy? And so without going into the story, I've told it several times, naturally, you know, we would be interested in doing that, but we want to make sure that all the decision-making people, and as a corporation, we're going to undertake this, you know, this is going to be something serious. And from the standpoint of those of us that have to do the work, well, we're already familiar with the locomotives that we operate. The 844 and the 3985 and the logistics and the complexity of having that type of equipment out on the modern railroad. So we started to talk about all the infrastructure things that we would need, the logistics. I wanted to make it very clear that this isn't going to happen overnight. We don't even own one at the time. So there's all these other decision points that we can reach. But I wanted to make sure that everyone was really firmly behind the concept. As time goes on, there's succession. There's people that move on and they retire and other people come in. So one of our big part of our role is to continue to educate and not only fulfill the public relations side of what the STEAM program does, but also fulfill the internal public relations side of what we do. We're very fortunate that the Union Pacific supports this program as they support everything that they want to do. We build that support by showing them we can do what we say we're going to do. And the other side of that is they support us. So that's where the facility upgrades come into being, and talking about 5-year, 10-year, 20-year planning for the infrastructure, for the buildings, for the locomotive, for the support cars, for the roundhouse, every aspect of the Heritage program. Then we have our counterpart in Council Bluffs, which is the passenger car fleet. They're very much a part of this picture too. So a real interesting time for us. We get to chart the course for what it is we're going to do and how we're going to do it. That big 40-ton crane, naturally we'd like a really big heavy-duty crane. But like everything, it's a business decision, and we got to factor out, okay, what does this cost and how many times are we going to use it? So we're going to get a nice usable crane in the very upper level in the shop. So we'll be able to do a lot of the things that we haven't been able to do, or it's very difficult to do. For example, when that acoustic ceiling tile was in the shop, it was pretty low. It was hard to work on the locomotives. And of course, the biggest problem was it was just filthy, and it was about to fall in from, as many people have heard me tell the story, and I'm not kidding, full of pigeon stuff. So it was real good for us to get that out. We get to upgrade the lights, put heat back in there, and upgrade the facility. You know, making it more toward a locomotive shop again. Taking out some of the ramps. When we work on the equipment, it's hard to, because we've got those diesel ramps in the way, and it makes it difficult to work on stuff. So it's really exciting for us. Things don't happen overnight. You know, if it were ours and we had unlimited resources, we'd be done with just about everything. But everything has to fit into a plan, and a big part of the plan is that we run the excursions, the steam trips. Well, this is the crew that does it. So when we're out doing that, there is very little or no work going on the other projects. So it's exciting for us. We try to fit it all in. So what we're going to talk about is what we've done on the big boy, and we really hit the ground running. For a small group, we really get a lot of work done, a lot of productivity in an 8, 9, 10-hour shift. We got some guys working today, and several of us will be working tomorrow, because we want to get the project completed when we said we would, and that's 2019. Anything can happen. To try to do it, we think we can do it, and so without any further ado, I'll get started on talking about where we are. As I talk about things, I don't mean to put any one person on the spot, but I did bring my very patient and gracious wife with me. And I've got two of my staff, Jimmy Thompson and Ted Schulte. So I just want to say up front, I'm not trying to embarrass anybody if I'm asking them to stand up or anything. And I would never try to embarrass anyone. So I'm going to sit down here and let me know if you can hear me okay. So this was back in December. We needed to take the locomotive apart. And interestingly enough, my intention was to do this same thing to the 3985. So this is nothing new. Was some idea we came up with just the other day. I wanted to do this level of work to the 3985. With all big machines, you got to take them apart and work on them. Well, that's a big locomotive to disassemble. Well, now here we are with the big boy. We've got an even bigger locomotive. Well, how in the world do you lift this thing up? We don't have a crane anymore. So we contracted with Holcher, and they've got two 70-ton hooks that they can bring into the shop. Well, at one time, Cheyenne had 4 70-ton hooks in the shop. So we used 2 of those hooks, and here we are after we pulled the front engine out. Look at the smiles on the faces. It was really cold that day. And as I mentioned, this type of work is very specialized work. It's not your average job where you go to work and you come home. And we can't do it without the support of our families. You know, our wives especially, and our children, for those of us with children. So with that, this is dedicated to my wife, Nancy. Here we are in the cab of the 844, and over my shoulder you can see Bruce Kirk. He's one of my outstanding machinists. I told him, you don't have to wear your hard hat in the cab, but he is so dedicated to doing everything right all the time. So here we are traveling just this last fall on the Memphis trip. It's also dedicated to the crew that did this tremendous work scope on the 844. We didn't intend to have that locomotive out of service as long as we did, but as I've told in previous presentations, we found a lot of things wrong with it that we had to fix. And that's our role, is to fix things, not to look the other way, not to come up with a reason or figure out how we can run it if it's not right. We've got to take it apart and we've got to make it right. And there's the locomotive when we were out in Memphis. And there's the staff. Just a beautiful shot of the locomotive. I've heard from a lot of folks that have seen the locomotive and known about the locomotive for years. And one of the first comments they said when we started running it, "I've never seen it look better. Oh, that locomotive looks better." And what we would tell them is it runs as good as it looks. And so that's really quite a compliment coming from those people that have been familiar with the locomotive. And here's the staff. This is right when we got right back to the shop and we put the engine away. Everybody wants to go home, but we need to pose for a photograph. It's not the best picture because of the lighting in the shop, but you can see. I'm going to see if I can use my mouse here. That's part of the crane way. But we've got my wife Nancy, my fireman Ted Schulte, who's over here. He's been my fireman since 2010. He and I, the two of us, have been the engine crew until we've got some additional qualified steam people with us. And there's Bruce Kirk. Let me get my mouse going here, forgive me, bear with me. Bruce Kirk, machinist. Kirk Clark, locomotive engineer out of Cheyenne. He's our second fireman. Don Creer, master boilermaker. And next to him is Jimmy Thompson, who we have with us today. These two here are my two code welders. When it comes to welding anything under any circumstances, they are absolutely top quality. And below Jimmy is Garland Baker. Just as we need that high quality, superb welding skill is the machining skill that Bruce as a machinist and Garland as a machinist bring to our program. I'm kneeling down in front, and we have Austin Barker, who unfortunately couldn't make it today, but he's our locomotive foreman. He's not even 30 years old. And I've known Austin for some time. He joined our crew in 2010 along with Ted Schulte, and he's proven himself. He loves this stuff like we all do. But Austin has an aptitude for mechanical things, and it's kind of interesting in our life. I guess it's not popular to say that you like trains if you work on the railroad. You know, they'll tease you about it if you let them. They'll call you a foamer and things like that. I've never taken exception to the word foamer, but sometimes you hear those names bantered about. Well, Austin, when he was 10 years old, had a bumper sticker that his father got him of the 4014. Don't know how that came about, but he showed me a picture. I've always liked all big steam locomotives, so it's just interesting how life plays itself out. We also have the tremendous support of the entire infrastructure of the railroad, all the different departments helping us do what we need to do. And that's part of supervision and management's responsibility to follow the rules. And you've got this big vast corporation. There's specific ways you buy things and do things and order things. And getting to know that system and fitting the steam shop into the rest of the railroad culture is just as important for us as it is for any other department. Helping us do that is our boss, Scott George. We celebrate birthdays in the shop and we have a good time. We get to know each other really well. And Scott has a very extensive background in mechanical shops on the railroad. And it's probably not impressive to some people, but it's very impressive to me how well he runs an Excel spreadsheet. I think his business acumen is outstanding. He's a very good supporter of ours, and that says a lot about the Union Pacific and what they want to do with the railroad. Why would they want to bring people in to get familiar with the steam program? That's longevity. You know, we could easily just close it down if things aren't going right or somebody's not happy. Well, oftentimes that's what happens. But what the Union Pacific does is they plot out a good strategy, and that's part of that plan. And Scott's just been a real ally of ours, and he's right there with us. So he can see how things work, he can learn how things work, and he can see how we work. And he's just, the things that he says about our production and the stories that he shares with his experiences in other shops really kind of sets us apart and kind of gives us that support that we need. I always have dedicated the entire program to Ed. He was a very good friend of mine, a good friend of Ted Schulte, Austin Barker. He was a steam engine person. And if you like steam locomotives and railroading, he was your friend. Ed Gerlitz did just a tremendous amount for the railroad community, the rail fan community. UP Steam, for years, he served as the trip chairman for the Rocky Mountain Railroad Club, and in that capacity, he helped set up just a lot of really good trips with the Union Pacific Steam program. So we're going to jump right in, and here we are on a cold, snowy night. We can't control the weather, and this is another reason why we need to have some cranes and do much of the work inside if we can do that. So we're getting those big 70-ton hooks lined up so we can pick up the front of that boiler. We've already disassembled what we call the hinge pin or the articulation pin, and we've spent a lot of time disconnecting all the pipes, the reach rod linkage for the valve gear, the steam pipes. Some of that we did in California because we knew that we were going to need to bring the locomotive home. We didn't want to have to worry about lubricating some of the stuff that would have to move, so we disassembled it back in California. So as much as I can, I try to document this in an up-close and personal way with our phones. A lot of us take photographs when we can, but it is a busy job. We're paying this derailment crew quite a significant sum of money per hour, so we don't want to dilly-dally along too much. So we're beginning to pick the locomotive up, and you just get some really interesting shots. Just something that you don't see every day. You can go down to the park and look at a big boy, but looking at one and watching it come apart and being the first person to climb under it, or watching it come apart, or something like that. I know it's kind of corny, but we have a lot of firsts. That's a neat shot. So as much as we study and as much as familiar as we are with ALCO, with UP Steam, with our locomotives, there's always elements of a plan that are really difficult to really completely map out. And one of the challenges that we had is we figured when we unloaded the weight off of that front engine that it's going to have an effect on things, and we're going to have to raise that up because the spring rigging and everything is going to, as it releases that weight, that frame is going to just move up a little bit. Well, it tightened the brakes. So we had this idea, we were going to pull this thing out with basically a big forklift. But like anything, if it doesn't work, we've got to do something else and do it quickly because we don't want to dilly-dally. Well, we ended up pulling that thing out with the switch engine, and it was about all we could do to pull that thing out with the switch engine. Well, if you realize just how big the big boy is, and without getting into the technical nuance of how big the big boy is and everything else, it's effectively two 844s. Think about the engine unit, think about the cylinders and the valves and the frame and the brake rigging, the axles, the roller bearings, the drivers, everything that front engine unit represents. You're not far off from what the 844 is as a single locomotive. Well, you pull that front engine out, and there's essentially the 844 without a boiler and a trailing truck. So this is just a huge piece of machinery. Well, having had the drivers out of the 844 multiple times, and back in 2011, we did a very comprehensive work scope on the wheels, on the connecting rods, the main rods, and the pistons. We know what that work scope entails. So you can just see the magnitude of the size of these components. These leaf springs here represent a real challenge for us. They're the only spring we can't really get anybody to make. So we're probably going to have to make them ourselves. We've been looking at the UK, we've talked to them, we've talked to folks in Germany, we've talked to folks in Canada, and all the big companies here in the US, and nobody can handle the 7-inch wide, 54-inch long, 30,000 pound capacity leaf spring. We've got some blueprints that we brought here, just if you'd like later on, we can look at them. But I think if it's okay with everybody real quick, I'll just point these out. I'll come around the other way.
Is that the information there?
These are the same springs on the 844 and the Challenger. It's called a number 623 spring, and they're reverse camber. When they're made, they're flat. Well, that's just a huge spring. When I worked down at the Durango and Silverton, a big guy could take and put those springs in. On smaller locomotives like at the Georgetown Loop, you can muscle those in, or one or two guys. You need a forklift. They're just huge. The other thing is how the locomotive is built. This is called an equalizer over a driver, because you've got the centering device mechanism here, so you can't have your springs up high. You've got coil springs down on another set of equalizers here. But the locomotive is designed, and it's so compact, it's just a masterpiece of design. And I learned that the hard way when I went to California when we were all out there. When we were first starting to prepare the locomotive to come home, I wanted to make sure, we did, that we were going to take care of those roller bearings. The locomotive sat in a park for longer than I had been alive. And I was adamant that I didn't want to move it until we got in there and cleaned the roller bearings up really good. And we made sure everything was good. There were no conditions that if we would move it a little bit, we could potentially cause some damage. Well, as we got down into the frame there, the problem was that they had asphalt paved right up to the road, like a lot of museums do, right up to the top of the rail, and there was no humanly way that this skinny person couldn't get down in there. So we cut some brake rigging, we moved it out of the way, kind of moved stuff, and I could only get into 3 out of the 8 axles. So we had no choice but to move it. But as you get into this, when you look at the pictures here, when they designed the big boy, it has to be as big as it is, to be as powerful as it is. To take advantage of the 300-pound boiler pressure, it has to have that weight on drivers so it's not slippery, so it can deliver the tractive power it needs to. Therefore, it's got to be big. The problem the Union Pacific had is they have an infrastructure, tunnels, for example, and that was the limiting factor. So you just couldn't make this engine that was physically enormous compared to the other ones, so they made it as absolutely as big as they possibly could. And that's what you see when you start taking it apart, how these parts are fit in there, and how you've got to systematically take it apart. You just can't, like the 844, take these pieces off. You've got to be strategic about it, and there's actually drawings that show the sequence of removal or application of a lot of these parts. You go to put that engine together again, you're going to take it halfway apart again if you didn't do it right. Back to the 844 in 2011. The beautiful thing about this equipment is it last operated back in 1959. So it's got a lot of serviceability, a lot of meat, and a lot of life left in these components. This section here, and forgive me for those that aren't a technical trained person, if I kind of drift off into the technical world a little bit, but these bronze bushings are called floating bushings, and they actually run on the surface of this rod here. There's no liner or a bushing to take the wear as that component is going down the track. Well, when they built these, they were projected to operate into the mid-1960s, maybe the late 1960s, if they absolutely needed them, because they were such a good design. Well, what does that matter? Those rods will never wear out. Well, here we are, it's 2017. How long's that 844 been rolling down the track? So you've got a lot of components that are getting pretty worn out. Well, what you see right here, this is actually running on the rod. That's not a bushing. A lot of the locomotives in Durango, Georgetown, a lot of the locomotives that you see around the country, they've got replaceable liners. So the rod, effectively, unless you damage it or bend it somehow, it's going to last a long time. These rods aren't set up that way. And this represents a lot of weight. They're 73 inches. I'm 74 inches tall. 73 inches between each one of these bores. And look at the weight and the massiveness of these. And these main rods are 3 inches longer than the 844s. These are 138 inches long, 844s are 138. And there's a close-up. You can just look at this massive cross-section here. 844, this has been bored out a lot, and this section here, and particularly right in here, is getting a little bit thin. So the days of trying to make 100 miles an hour with that engine probably aren't going to happen. And here's a shot of the 844 work that we did. Beautiful new rod hardware. That's what the big boy will look like. Another shot here in the shop. And here's one of the big main crank pins. This is where that main rod connects to. We're going to make all new crank pins and all new rod hardware for this locomotive and all new tires. A rod brass.
Please come to the front.
And we do all this work in our shop. We're contracting with Strasburg. They did absolute beautiful work on the 3985 and on the 844. So we're going to outsource that work to them. And here we are dropping the driver in our drop pit. And it's a little bit hard to see, but you can see just how massive and how condensed everything is packed in there. Taking all of this apart. And here's that equalizer that I pointed out over on the drawing over there. And in order to get the equalizer out, you have to disassemble the bottom part of the frame. And in order to do that, you need a table, our drop table, because this pedestal binder is beyond the limits of probably 3 guys or maybe 4. It is a huge piece of steel. And as is that casting. The other interesting thing about the locomotive is it's just such a massive machine. It's got some wear in the pins and bushings on the spring rigging and brake rigging, but again, considering it last operated in 1959, clean it up, bore the holes, make them round, put new bushings in, paint it up, put it back together in many cases. We also have all new pedestal bolts. That's what these are. I actually brought some with us. Did we have those up there? We had those made, just like on the 844. We just make all that equipment. We just make it new. We don't use the old rusty bent up bolts. We just make all new bolts for it. It goes back together with all new components. Here's a frame fit on the pedestal. This is the number 4 axle on the front engine. And look at the beautiful condition. The picture doesn't quite show it, but that's in really good condition for sitting for 5 decades out in the weather, the nice Southern California climate. All these springs down below, in order to get those out, when the locomotive was in service, there was oil flowing to all the force feed lubricator lines, so that thing is just flooded with oil. Well, then you take it, you stop using it, and it goes to a museum, and it sits for 5 decades, and it solidifies into this stalagmite of dirt and what used to be oil, and you've got to chisel it out of there. So one of the things that we did when we first got out to California is we called it schlickum. It's just our little name that we called it, but it was an oil and solvent solution, and we actually, don't tell anybody this, but before we even got the negotiation completed, just in case it would be approved, we started that. So we would go from one end of the engine to the other and just start saturating it with basically rust penetrant, freeing up all the springs and freeing up everything we could get to, and we did that. And we told them when we left, hey, go ahead and do that again. We went from one end to the other and to the other and back and back and back, because there's certain parts of the engine that we really couldn't get down into, and we were going to bring it home to Cheyenne, 1,300 miles. So we wanted to make sure everything was moving. Well, there's such big surfaces in there, and it's called a shoe and a wedge, a big bronze piece. You've seen how big they are. They're just enormous. On smaller locomotives, you can pick them up. On these locomotives, they're almost too big for one person to lift up. So we oiled in behind there, we cleaned it all up again, and when we took it apart and cleaned it up, that's what we discovered. Now we've got the front engine, and we're stripping it completely down. Got the air pumps off the front, what we call the pilot deck. This is where the headlights mounted, right up here. That's all part of that one casting. Think about what that must have been like back when they cast these frame units back at General Steel Castings, south or east of St. Louis at Granite City, Illinois. What a huge piece of iron, steel. This is a valve bushing, and we actually brought one of these with us. We're going to put all new rings, just as you would in any restoration project, new valve rings. And the valve bushings are such as that they're at the end of their the maximum diameter that they can be. So we've got to source and fabricate that component there. It's called a valve bushing. It's a cast iron, and in order to do that, we have to get it out of there. And we're going to do the same thing on the pistons. We don't have to put liners in the pistons. They're big enough, but they'll be oversized. So instead of being 23 3/4, it's going to be 24 by 20 by 32. So it's going to have big cylinders, which will make it more powerful. So we'll take these bushings out, and we have to bore that. Well, at the same time we're doing this, guess what? The 844 needs that work too. So we're doing this and we're doing that at the same time. Not really what we'd like to do. We'd rather just run that 844 and just get in, turn the key on, and just go. You've got to do work on it. Those valve bushings in the 844 are old and worn out. And the rings, when we came back from Memphis, they've been blowing for a few years. And when they came back from Memphis, you know, I told Austin, I said, we're going to have to make new rings. We thought, well, on top of everything else, we've got a trip in April. So we've got a month to do all this work and keep working on the big boy. But that's what you're going to do if you're going to run steam locomotives. And this is the valve stem guide casting. We take those off where we're going to do it, so we'll work through those and rebuild those as needed. So little by little, bit by bit, we go through little pieces of the locomotive and continue to do what we need to do. This is the front part of the connection between the boiler and the front engine. A big wear liner, we'll replace that. And the centering device spring, that's one side of it there. And that's what makes allows the boiler to move. And we've got a drawing right over here, right there. That's the centering device. So what you're looking at, here's these two springs. You've got an inner and an outer here, and an inner and outer, and then a spring seat, and then these big spring rod pockets. This is connected to the frame, and the boiler's bearing all of that weight on this big giant liner. Well, if you look at the old days, Moffett, Malleys, all articulateds had the same design. So it's what's really interesting. You look at the old Moffett Malleys, they had a miniature version of that. So it's interesting for us. That's one of my favorite locomotives is the old Denver and Salt Lake Malleys. So looking at this is a big Malley. But you look at the springs in there and what they're designed to do. As the engine truck starts to encounter a curve, it begins to pull that front engine unit over, and those springs begin to compress by those rods. And the rods really aren't that big around. They fit in these big castings, and that rod begins to influence the boiler, or the boiler influences everything, and those springs begin to compress, and then that boiler moves around, and the engine unit comes back around. And the tighter the curve, the greater the force or the resistance on the spring, which as the locomotive comes back out of a curve, everything is lining itself up and being aligned just right. Well, as time goes on, those things wear out, and all that action is diminished somewhat. So like everything, there's standards of wear and everything. Some of those components are in good shape, others are a little bit worn out, but we'll take it completely apart, make it all new again. And we actually have all the springs, I've talked about that before, we bought all the springs almost 2 years ago. So all the coil springs we already have on hand. Just a matter of getting it all cleaned up and put it back together. Here's another interesting shot of the rear engine unit. We made a drawbar to connect to our dolly truck, so when we do move it, everything stays together. We've got a lot of piping, air piping and steam piping to restore. We've got to disassemble the rear engine unit. Because it's such a big, massive, condensed locomotive, you've got to take all that stuff apart to get down in between the frame to work on this. There's the front engine being suspended by the dolly truck. Now we have all the spring rigging removed from the engine unit, so we can go through and rebuild all of that. Now here's the drivers. The first set of 4, these are actually the box known as the cannon box here is inverted. So this is the bottom part with the drain plugs in it. We clean these up. Jimmy spent quite a long time with the pressure washer, and Ted is they're always they just work endlessly cleaning this equipment up. You can see the old writing back from the 1950s, 4014. This is a centering device, constant resistance centering device or lateral motion device. We have all those springs as well. We'll rebuild all those wear surfaces and restore the relationships of all those dimensions to make sure it works perfectly. And these are the access plugs that we were able to get into when we were in California, when we finally moved the engine a little bit so we could climb underneath it. Ted and I spent 5 days going through all those boxes. We did it 2 times there and another 2 times when we went to Colton. Well, now we've got them out, we can really look at them. And thanks to Jimmy cleaning these, you can see the roller. It's a little bit tough. This is the actual roller right here. There's a cage that keeps them in the right relationship. This is the axle. This is the race. But those rollers are just a little bit under 3 inches. There's 22 of them, 21 on the main. That big by that long. So it just gives you an appreciation of the massiveness of the locomotive. The big boy is reputed to have over 1,200,000 miles on it, but not all the drivers are from the 4014. We got the 4008, the 4000, the 4004. So there's a mix match of all the different driver sets. And that was really common in those days. So no one knows how many miles you have. Some of them might have less, some of them might have more. Now we're inside the boiler of the big boy. We've got both tube sheets removed, and when they put tube sheets in these locomotives, they were in the practice of removing the first 1 or 2 rows of stay bolts, as you'll see. We're doing the same thing. Big reinforcing plate, big liner, big strap, heavy rivets, but in remarkable condition. And I'm pleased to say the inside of the 844 is in very good condition. There's some corrosion down on the bottom, down on the very bottom of the locomotive, but it's not bad enough that the locomotive is in jeopardy. But this locomotive, everywhere on the inside, is in really remarkable condition. Here we are looking at the outside of the locomotive, and the same is true there. There are places back near the cab. It sat next to a grove of trees for 25 years or so, and a lot of pine needles accumulated here and there, and that did some damage. But all in all, the locomotive's just interior and exterior is just in really good condition. This is a shot of the 844 just to illustrate the combustion chamber and the connection of all the stay bolts. And here we are looking at those 2 rows that were modified with a different type of stay bolt cap so they could be removed on an annual basis if needed to replace those tube sheets. Some of the tooling that we've made to facilitate all the stay bolt cap and sleeve work. And now we're inside the firebox. We don't have to do as much firebox work as we did on the 844 last year, so that's good. We did a heck of a lot of stay bolt work and firebox work on the 844. So I apologize if this, I don't think the audio is going to work really well, but what this is one of the tools, driving rivets, and we're actually putting the mud ring back together again. It's probably a good thing that the sound doesn't work because it sounds like a machine gun. But the rivet comes through at 1900 degrees, and we've got one of us on one side with what's called a 90 gun, which is a huge rivet gun. And then we're using the double gun technique, so we've got the other guys on the other side, and we'll show that again.
You're in the way.
Oh, sorry. Thank you. So the rivet comes through 1900 degrees, and now you got to shape it. And of course, when it comes through, it immediately wants to bend because it's like a wet noodle. And you've got to take that huge gun and you've got to work it around and then just form that head. And it's a countersunk head in the mud ring. We did 150 of those in the 844. And here's one of the mini stay bolts that we're working on. We did the same thing on the 844 here. And that's a cap removal tool. The stay bolt caps, they're actually welded on. A different design than the sleeve and the threaded sleeve arrangement like these. That's threaded on. This is simply welded on the exterior of the boiler plate. It allows for a lower profile assemblage, which is what you want when you have to design a locomotive that's almost too big for your tunnels. So you want to come up with every little construction technique or engineering technique to maximize the overall dimensions. And that's how these particular designs, a Flannery design, came to be. We make all these or have these parts made by the thousands. And now this is on the inside of the firebox. And if you think about what a big boy does, how does it do that? How in the world do you create nearly 7,000 horsepower? How much coal is that going to take? How much coal do you have to burn in 20 miles going up a hill pulling a 3,000 ton train? How much coal is that? Well, that amount of coal goes flowing through there like a sandblaster. And what happens is it starts to erode parts of the firebox. Well, they were not getting the mileage out of the equipment because that end of the stay bolt was just being sandblasted away. The voracious appetite of that machine and the tremendous velocity of the exhaust created so much draft that those cinders and that coal was just flowing up through there. So what they did is they welded these little metal pieces of wire called eyebrows. So that was sacrificial. And you can see around here, those eyebrows, many of them are eroded down. And parts of the sheet is just eroded away. As if you stood there, if you've ever done any restoration work and worked on sandblasting, you know, it's really aggressive, and you hold it on metal and it just strips the rust right down. But if you hold it a little bit more, you're eroding that metal away. Well, that's the same thing in the firebox. So there's sections that we have to remove because they're below the minimum thickness. So we go through and we analyze all that. Any welds or any of the areas that aren't up to speed, we cut out and we'll replace. That's one of the stay bolts that has to go. This is a drawing of one of those stay bolts. This is it right here. And here's we put some layout dye on there and make sure that it fits the way it's supposed to. And this is in the water space. The 844 looked just like this. This area right in here is called the mud ring. And here's part of a patch that we're putting in. So we go through and we find any problems and we correct them by welding them up and making a template and fitting it all back up again. A picture of some stay bolts that we have. This one we removed out of the big boy when we first brought it back. This was taken out of the 844, and this was a stay bolt that we had in our inventory. A lot of the equipment we had in our inventory didn't have any identification markings or any paperwork on it, so unless we want to spend a little bit of time and money, we can't use it. So if we want to use it, we want to cut it, randomly select pieces out of there and make sure that it is what it's supposed to be. And just looking at the location of that telltale hole, it's not quite what it needs to be, so we can't use that. Two stay bolts out of the 3985. There again, as we take these, we want to learn why something is having a problem. Why is it rusting so bad? Why is it leaking? Well, in order to do that, we take it apart, analyze the type of material that it is, and then of course that level of scale and that level of corrosion is a very bad thing. Here we are. This is back on the 844, the same type of work that we're about to undertake on the big boy, fitting those plates up. And we fit those plates up largely by hand. We have a big press brake that we can actually form and bend the metal, but that only gets you so far. You have to use other devices. I'll explain those in a minute. This is a tap and a reamer. Probably pretty boring for the non-boiler type people. But we made all new taps and reamers. And you're running that with an air motor. So you want to line everything up. And as it's cutting itself, the computer is running slow, it reams the hole through, and then it begins cutting threads. And you want to cut the threads in the outside on a common lead, meaning that you can screw the bolt in on the outside, and it picks that thread up exactly on the inside. So you want to run everything in on a common lead. That's actually a good shot there. Let's see if I can get that to stop. We've got a little screwdriver wedged in there just to hold it apart, just enough. But you fit all that stuff up very precisely, and then start threading and putting the bolts in, and keeping everything lined up, one bolt after another, so when you install them, they're all taking the same load. None of them are taking a little more or a little less. Some are loose, some are tight. We get them all in there exact. We do them all exactly the same way. And there's the piece of plate that we're fitting up in there. That was a real heavy son of a gun. That's how we formed the plate. We have to bend these little radiuses in it, so we made these forming dies so we can get into the drawings. I have a picture of a boiler elevation over here, and it shows you the dimensions of each one of those sections of the boiler. So we can take that, we can draw those plates in CAD, weld them all together, and now we have a male and a female die with that precise radius. Now we can take and lay that sheet out, take it over on our 100-ton press, and then we can begin by hand putting those two pieces together and forming that radius. Move it over a little bit and form that next radius. Just painstaking. Take it out, go fit it up in there, see how it fits, bring it back, and the thing's 140 pounds. So you're over there wheeling it over, make another adjustment, bring it back. But once you get that in there, it's the only time you're going to have to do that level of work in maybe 30 years or more. So that's why you want to take that time and fit those sheets up exactly right, because then our welders can come through and now they can weld a very precise two pieces of metal together. That's not moving like this. It's wide here and narrow here, and it's exact. And they come in with that weld, and what you have is just an outstanding quality job when you're done. So, and there they are, just thousands of man hours of work. My computer's running a little slow. It might not run here. Let's see if I can get it to run. So this is how the stay bolts are formed. That's a 60 gun, not as big as a 90. And if you can hear that, it's really loud. That stay bolt forming tool begins to form the head of the stay bolt. And as it does, it's got a small tip that drives through this hole and expands the bolt out. And that's what helps seal that. That's what you want. You want to make it steam tight. Over time, if it's not sealed, if the bolt's not installed correctly, my computer, it's always funny. You watch it all day long here, but when you plug it up to a projector, it doesn't run. But if you don't form those threads correctly, over time, that water will get in there. And if you don't have adequate boiler chemistry, if you've got too much oxygen in the water, well, what does oxygen in water do to metal? And it forms an oxide, forms a corrosion, and you'll see that on these stay bolts up here. So that's why you want that stay bolt formed exactly the way that we're doing it right here, because it drives that tool down into that, what we call a telltale hole, and it expands it into the threads. Because you can thread it in there by hand. Well, that means the water can get in that thread too. So the next step is to drive it. And then the other side of that is you've got somebody bucking it. Well, when you have to do hundreds and hundreds of stay bolts, you either have to be the Incredible Hulk or an Ironman triathlete. You're not going to be able to physically withstand that work. I mean, it's agonizing. It's agonizing. We're not complaining about it, but what we do is, so we've got to come up with a way how we can hold on to that bolt exactly the way we want to. So we tried this, we tried that, we're holding it. Some guy's standing behind me holding me, and he's got this, and we got a strap, and we're trying to do it. So you do two of them, and you're ready to go home. So we're like, this isn't going to work. So we took one of our welding tables, and we mounted it sideways on the front of our forklift and welded and strapped it down, and we picked it up, and we could lean that big giant welding table up against us, so now you could have something behind you. And then we made this device with an air piston that would hold it. So the guy on the inside would stick a wire through, and the one that the wire came through on, I would hold it with that air device, and I would stick my wire through, and he would hold it with his air device, and then I would work the one on the outside, and he would work the one on the inside, and then we just switch. And we got through it. It was still agonizing. You know, Jimmy was over there doing it. I mean, we all took turns at it. But it's one of those things that when you start a project, everybody wants to do it. But after you've done it, you look around, it's like, is it break time? No, I don't mean to imply that they're killer. So this is what it looks like when it's done. Is the material is formed really nice. You guys didn't think I could talk 20 minutes about a staple, but it's important. So it's driven here, expanded out, and you've got this beautifully formed head that's tight. Well, now, when you've got that big 2,000-degree fire in that firebox, you can't really see it, but there's a small little lip there. You can't even hardly feel it with your finger. Well, that fire can find that, and what's going to happen is that metal will eventually get hot and it'll peel away. As soon as it peels away, the heat's no longer transferring into that sheet where the water is. It's going to get too hot. It's going to deteriorate. It's going to crack. And what do cracks do? They propagate. And then you've got a bad problem. Now you got a leaking staple. So what the UP did, and a lot of railroads did this, they studied boilers, how to make them work the best, how to get the most time out of them. And what they came up with is a technique that we use. It's been in use since the late 30s. And it's the same technique we use. And we have our outstanding welders weld that seal weld, and I'm telling you, they all look that good. So the seal weld now ties this metal into this metal. It's all nice and low profile, nothing sticking out where the flame's going to get it, and it'll last forever. Well, excuse me, it'll last a long time. And there's the plates coming together. And we just don't have that much work on the big boys, so I really can't show you much because we don't have to do that much. Now here's the combustion chamber. The tube sheet's been removed. The first or the last two rows of stay bolts have been removed. Now you can look from one end of the boiler to the other. Another stay bolt cap or sleeve. And there it is. Some studs that we'll have to replace. Let me just systematically go through and clean up everything that needs to be cleaned up. If it doesn't look right, it comes off. Make it new. Clean it all up. That's where those stay bolts run through right here. Lots of air valves and every part of that locomotive. We've got bins and totes, these plastic forklift totes full of all the various parts. And we'll randomly go over from our storage unit and we'll pick those up, and then we'll start going through. Ted, Jimmy, the guys will just randomly go through and just start cleaning everything up. Some of it's not so random. We go down and we clean the pipes up. They come back and they may be too deteriorated for us to use, so we'll have to chop segments of them out or make an entire new pipe. Not so bad when you're talking about a half inch or a 1 inch pipe, but you get a 2 or 3 or 4 inch pipe, you've got your work cut out for you. Steam valves on the bottom part of the boiler that we'll rebuild. A lot of these components we'll have to just remanufacture. They're just too far gone. That's a steel ball and a spring, part of a valve arrangement. And after they've been rebuilt, a lot of these that we used on the 844 came off of the 4014. They were in such good shape, so we've rebuilt all of them at the same time, just set up an assembly line and go through and rebuild every component. There's the finished product right there. Water glass hardware. Here's one over here. It's actually bent up. It was leaking and it was just tightened down and continued to be tightened down. It started to bend that up. And as it did, it cracked that flange. Not something you want to find at 300 pounds of steam pressure, so we made new ones. Valves and valve stems and rebuilding all of these components. They're so heavy duty, they'll last, as obvious by their condition here, they'll last forever. But there are parts of them that you've got to go through and rebuild and make new. And as you're doing that, this top one came out of the 844. So sometimes you'll get some water in there. So when you store the locomotive, it's important that you try to dry it out as much as you can. We've started a practice where we actually have very large 480 volt electric heaters that we put in the boiler inside the firebox. And the theory is that we clean it very carefully, very thoroughly, and then we air it out, we let it dry out, and to continue to drive the moisture out with those big giant heaters. And that's the way you want to store a steam locomotive. If you bring the locomotive home wet and you let it sit around with water in it for a while, that water is very corrosive, so you got to get that water out. The water that you've used to clean it is oxygenated by that atmospheric air that we breathe, and that cycle of corrosion is just constant. More parts. It's really exciting. Maybe we're kind of train geeks, I guess, but we go by and we'll watch Garland and Bruce make these parts. And we've got some drawings, and I brought some of the components that we've made. So if you're interested, you can come up and actually hold them in your hand and look at the drawing. They're just works of art in their own right. Big giant turret valves, and the picture doesn't really do justice. The turret valve, each one of those is about this large, and it's a 3-inch valve, and it's obvious that you want to be able to shut that steam pressure off, because a steam locomotive is not like a car where you turn off the ignition and walk away. The pressure vessel is under pressure. When you have a fire in it, then the theory is that you keep the locomotive at maximum pressure all the time. Big 300-pound pressure vessel. We don't run it at 280, maybe 250, 260, 270. No, we run it at 299, don't we, Ted?
Yes, sir.
So in order to do that, if you have a problem and you've got to shut something off downstream, you've got a couple hours worth of drain in the boiler, which you don't want to do, or you need to be able to shut that off. So by having the valves serviceable in a new condition, now we know if we do have a problem, we can shut those valves off. There's the front top check. Pieces of the spring rigging component and new springs. So when this locomotive goes together, as I mentioned before, it will truly be a frame-up restoration. Inside the firebox on the 844, and I included this one because this is essentially how the big boy will look. This is the same theory that we'll use on the big boy. People often ask us, what about the oil conversion? How are you going to do that? Are you going to use some kind of injector, multiple burners, some type of lawn sprinkler in there, multiple garden heads? It's funny that it's interesting how many different theories and ideas people have. But the most important thing on a locomotive is its simplicity. The more complexity you introduce, the more potential trouble you can have. So a locomotive oil burning apparatus, we're not talking about a modern piece of equipment where we're dotting the I's and crossing the T's on every penny of fuel that we have in there. If that's what you're looking for, run a diesel. This steam locomotive, by its very design, is not efficient. That people speculate about, well, we can do this, well, we can do that. A few years ago, efforts were made to make modifications to the Challenger, and they unfortunately were not a success. And that just underscored the American Locomotive Company and the Union Pacific Engineering was sound, and that's the direction we need to go in. You got these big giant pieces of refractory that we have custom made, and the process of putting that firebox and the fire pan together is actually, it comes together pretty quickly. We also made a new MU controller, and we've upgraded our, or rebuilt the air brake system in what we call a safety control system. That's part of our cap signals. Eventually, we're going to be talking about the PTC and what we need to do to put that into the locomotive. So we rebuilt the MU controller, and that gives us the versatility we need to operate the steam locomotive with other locomotives. As much as we all like to think a steam locomotive is the most powerful thing ever, and it can pull anything you couple it to, the reality is it does have its limitations. It couldn't pull the Cheyenne Frontier Days by itself. And it certainly wouldn't get you there when you want to get there. So we need to have a diesel in the consist with us. Several years ago, we had a problem with the MU controller, so we made a new one. As we investigated the problems that we had with that, we identified several conditions that we needed to fix, some potential upgrades, some safety features. So we integrated that into the MU controller. I apologize that I don't have sound, because for those that like the DD40, the 6936, we had that unit in the shop with us, and that's how we were testing this. That's another neat reason to have that false ceiling out of the shop, because if you need to run your locomotives, you can. So it was a cold day out, so we brought the 6900, the Centennial in, and we coupled it to the 844, and we connected the MU cable. And then I'll just explain it, and maybe it'll help you when I play the video. So Ted was in the diesel, and we were going to start going through these tests. First time we tested it. So we have to go through and test all the sequencing to make sure that it does what it's supposed to do. Now remember, the Centennial's in the shop. It's got two 16-cylinder turbocharged diesel engines, and I wish we had a sound system that could really do justice to what I'm going to show you. It's really something else. And I think the yardmaster in the tower wondered, what in the world are they doing in there? You know, this engine is in full run 8. You know, it's not generating full electricity, but we've got it in full run 8. So I would make the sound effects for you, but I don't think I would. It's got a little LED illumination there. You know what throttle position it is. And now the engine's revving up. It's in 5 throttle, 6 throttle, 7 throttle, 8 throttle. The whole building just reverberating. I wonder if my sound is on here. They probably can't hear it anyway. And then we go back down, all the way down, and you can hear the diesel engine going back down again. So now we know the system works. There's some technical things with the newer engines that we've got to figure out. The newer engines it doesn't seem to like, with all the different electronics that the newer engines have. Right above that is the telemetry device for the end of train device. And here we are getting into the tubes and flues. Before we get to that point, we've got to put the tube sheets in, and we're in the process of making those. We're going to make the front tube sheet. We're going to have the rear tube sheet. Mike Manueller out at Heber is going to help us make that. He's got a nice McCabe flanger. He's done it a lot. He really does great work. So we're going to have him help us make that rear tube sheet. And there's the tubes installed in the 844. New row of stay bolts we put in right in the crown sheet. And that's what it looks like on the inside of the 844 after we got it all back together again. That's what the big boy will look like. Lots of air brake parts. Same thing that we did on the 844. That'll be one of Ted's jobs. He'll clean those up, completely rebuild everything. And that about does it. We've got a few more slides here, but they're mostly the 844 work that we did, but it's going to be exactly the same thing on the big boy. Take it apart, make all new parts, put it back together again, and we'll build some test track out in the shop so we can figure out the maximum degree of curvature that we'll be able to negotiate, and how high it is, how wide it is at any given curvature. And so that will help us when we go to plan the trips. That's one of the more interesting parts of planning the steam locomotive trip, is all the little gyrations that you do in order to get in or out of big cities. For example, in April, we're going to go to Boise. Originally, we had planned to go all the way to Pendleton, but we've decided that we'll only go as far as Boise. There's some traffic and weather-related things up in the northwest that we're not going to go get the steam locomotive involved in that. So we'll go as far as Boise. So we've got to turn around. So there's a Y just outside, a place called Orchard, a nice big modern Y. So when we come out of Pocatello, we'll make a turn back about 30 miles into Nampa, and then we'll get on the Boise Valley Railroad and go down to the depot and have a nice event there. Back out 19 miles. You do a lot of backing up on a steam locomotive. A lot of the Ys, some of them don't exist. Some of them you can't use for one reason or another. A few years ago, we had an opportunity to go down to Phoenix, and they'd asked if we could go to Phoenix. Well, I don't know. I've never been there. So I get the satellite out and I start looking at things, and I go through all the engineering stuff. So I get on a plane and go down there and start mapping everything out. Figure out that, well, we'll have to head into Phoenix, but we'll have to back out. Well, the Y at a place called Picacho has got a 17-degree leg on one side. Well, that's a little too tight for us, so we can't turn there. So the only thing we can do is head in, have our event, put the Southern Pacific engine that we brought with us, have it on the rear, and it'll pull us backwards for 80 miles. Makes for an interesting photography, but it's interesting for us. People often ask, well, why do you got a diesel everywhere you go? Why don't you run that thing without a diesel? Well, a diesel, 99% of the time, it's not even running. But they don't know that. Just the presence of a diesel, I think, is something that is just objectionable. So, but we use it. It's a tool. We've got events down the stream a little bit. We've got switching to do. We need a source of compressed air when we need to work on the locomotive. Sometimes we'll have a specific locomotive that the company will want to use as part of the public relations messaging that we're communicating. So that's part of the reason why we bring diesels with us. A lot of times we won't take them with us, but it makes good sense, especially if you're going to go down a lot of hills. All the specialized equipment that we have, we've got special brake shoes, and they work just fine. But if you don't have dynamic braking and you're going to go down a long extended hill, guess who has to change those brake shoes? So, well, that's about it. I do have a few more pictures. If anybody would like to come up, we can look at some of the other locomotive air brake stuff.
Got a question.
But yes.
So what overall percentage of completion on the restoration of the big bore are you at?
His question was, what percentage of completion are we at? And I don't even know how to answer that. Some of it, some components are done and ready to go back on. Others are not. And so I would just be guessing. If I said 50%, I don't even know. I couldn't even hazard a guess. We're sending the drivers out to have those work done. 2 years. And you know, we've got a lot of the material that we've already ordered, and we have it arriving. Stay bolts have been made, all of our springs. Other than that big spring I told you about, we have a plan to have all those other springs made. Wheels for the tender, engine truck, trailing truck, you know, all of those things. You know, it's all mapped out on a timeline. So as far as completion, I would just be guessing, and I wouldn't want to get it wrong.
Did you say that you're on track for having it done?
Yeah.
The question was, could we say that we're on track? And that of course, yeah, we're on track, but I'll just qualify that a little bit. Anything can happen, but we, as I mentioned, you know, we work overtime when we need to progress the milestones that we're trying to knock down, and you know, we've got it mapped out. But as I mentioned before, you know, we're a 9-person crew, so.
Given technology today, is this locomotive going to be better than it was when it was built originally?
The question was, given technology today, would the locomotive be better? Well, when I think about that, I think about the workmanship of those that built the locomotive, and just if I were to suggest that, I don't want to send that message because of the craftsmanship and the engineering prowess of those that designed it, all of those that worked on those locomotives on the UP side, on the Alco side, and all of those that maintained them through the years. So what I will say is it's going to be something we're going to be proud of, just as we showed you on the 844 work. That's what you'll see on the big boy. The intention is this will be a public relations vehicle, and we want it to have maximum longevity, absolute maximum reliability. So with that in mind, that's why you see the detail, that's why you see the focus on quality and the focus on exact tolerances, proper materials, proper practices, proper operation and firing. I mean, the entire package is designed to achieve those goals.
2019, do you know where you're going to be going? So some of us can start planning vacations.
Boy, if I had those answers, we don't even know where we're going this year. I'm kidding. The Heritage Plan ebbs and flows. Opportunities present themselves. We seize that opportunity. The longer term planning, like the sesquicentennial of the driving of the Golden Spike, that's the key event, the promontory event. Now how that will look, we're still talking about that. We've got a lot of time, but it will soon be upon us. There's ideas about how that event will look in terms of the railroad celebration. You know, what locomotives will be used. You know, they'll come from this direction, that direction, maybe they'll go, you know, who knows what. But that will be the big event. We're committed by agreement to those, the Southern California chapter of the Railway and Locomotive Historical Society. We've committed to provide them a train comparable to what you see on Frontier Days. So, you know, the public relations needs of the Union Pacific will be satisfied, and then not long after that, we'll be starting to plan how we're going to make that trip look for them. Now, where we'll run with it, we don't know yet, but it's going to be in Southern California. So look for that. But as we plan these, and just along those lines, sometimes because the planning is so critical, and we want to be able to do what we say we're going to do, so we're not going to announce, hey, we're going to go to Boise, and then throw a plan out there, and then revise it, draft and revise, and you know, it's just not how we want to do that. We want to be able to lock down all our logistics, and then know that by committing to this plan, now we have to execute that plan. So that's why it takes a little bit of time to get the information to the public. I apologize if sometimes, if it doesn't seem like it's timely, but recognize that there's so much external logistics and internal logistics on the railroad. There's any number of maintenance away projects that occur all over the railroad all the time. And so we want to be able to fit our schedule in a way that's not going to disrupt them. And there's also the big public relations side of that too. We're working on other venues along the way. So that's kind of why it takes a little bit of time to get some of the information out.
When do you anticipate you'll start testing the big boy, like on the Greeley sub or someplace where it's fairly quiet?
The question was, when do we anticipate testing? We'll test it first in the shop, you know, in and around like we would anything, steam testing and so forth. As I mentioned, in my view, we'll construct some trackage and simulating various degrees of curvature and super elevation and so forth, so we can know the overall limits of the clearances, so we can plan that. But we'll run, the Greeley's a convenient one for us. We got a new Y down there in Greeley that's nice to use. Spear is a good one. Egbert, you know, we've got places we can go out and turn around and come back. But we'll do the necessary testing, but I'm pretty confident we won't have to do a whole lot of testing. We'll get it out and just run it. It'll work well. And I know it may sound a little bit corny by saying it this way, but I had an opportunity when I first talked to the group in California about giving the locomotive back to us. And they were enthusiastic. Not all of them were, but the majority of the organization was enthusiastic. It's something that they thought about, something they'd hoped would happen. So we immediately went out to the display and they took the bars they had in the window. It was in Los Angeles. They had bars in the window. And so we took those out. And I got down, I sat in the cab. And, you know, I'm very, very fortunate in my career, as a locomotive engineer. I've run a lot of neat steam locomotives. When you put your hand on the throttle, there's like a feel that you get. And it was the same kind of thing. Well, the 844 is just a great machine. Anyone who's ever operated that locomotive will tell you, and they, in their own words, describe what a fine machine it is. I've heard it described as a fine Swiss watch. Art Lockman refers to it that way. I've heard and read quotes of others that have run it. And I have to agree, the locomotive, you could take half the parts off of it and still run at 40 miles an hour home and you'll do fine. Challenger, on the other hand, the Challenger, no pun intended, is a challenge for a fireman. It's a great locomotive to run. And there's a feel on an articulated, you can actually feel the second engine. You can feel that engine up front. It's a sensation you get in your hand, the throttle and the seat of your pants, but you can feel that. When that front engine starts to slip, you know it, you feel it. So I sit down in the cab of the big boy, and they've got the bars out so I can lean out the window, and the first thing that hits me, because I know I'm just accustomed to that Challenger. Well, here's that, and a little bit more. And I'm thinking that running board just goes out and out and out and out and out and out. And then it starts curving in. And, you know, I use the cylinders to gauge where we stop. And you watch the rods as you stop because you want it to stop in a certain way so the guys can grease it. Well, here's the second set of cylinders is like crammed here. And there's a whole other set way up there. And I'm thinking, gosh, that thing's like way up there.
Well, that actually brings up a question. How much of a learning curve do you think it's going to be to learn to operate this one, especially since you're bringing it up from stationary compared to the other?
The question was learning curve. Well, not to oversimplify it, but a locomotive is a locomotive. And, you know, when you get to the point to where you can run a big steam engine, there's not a whole lot of learning curve in terms of the physical operation of it. There's nuance differences between grease fittings, for example. How much oil is it going to use? How much lubricating oil is it going to use? How big does the auxiliary reservoir for the valve oil tank need to be? Those things. How much air oil do we need for the air compressors? You know, all that kind of stuff. But as far as the machine itself, I started with a steam crew in 2004 and nobody told me anything. Next thing you know, I was running the Challenger. I've never run a big articulated in my life. I just got up there and you know, I mean, I'd been an engineer for years and I'd been running steam locomotives for years. So that sense of being familiar with it was no problem. Nobody sat down with me and gave me a test. Nobody rode behind me and said, oh, do this, do that, oh, here, this is how you do that. You just do it. I never had that luxury.
Threw you under it right just from the get-go, huh?
Now, when I was a younger person, I did have some great mentoring from steam locomotive era. Floyd Cothran off the Burlington, and originally in the 1940s off the Denver and Salt Lake. Hugo Lackman, Missouri Pacific, excellent mentor. And Irv August, a good friend of Ed Gerlitz. You know, so I've had the benefit of the association of some very competent, skilled men, and to help with that. You just pick up on things. Every converse, every, you know, and I try to be easy with the guys because I'll go in the break room and we're talking about that, we're going to do this, now we're going to do that. It's like they're on break, give them a break. You know, I'm talking about lubricators or stay bolts but luckily for me, they're right there with me. They love it. They're excited about it. They want to do the best they can. My foreman, Austin, I try not to bug him too much on the weekends, but we'll send text messages back and forth, or I'll get a picture of something, and he'll send me a picture of whatever we just made. So it's excellent, sir.
Yeah, why was that particular locomotive chosen?
When was
Out
what?
of all the.
Why?
Oh,
yeah,
why?
Why was this?
The question was why the 4014. That's a question we get a lot. I didn't go look at any other engine. Didn't need to. in my role, in my interest that I've had in my life, I've seen all except the 4012 and the 4017. I've seen all the other ones. Well, I knew they sat outside for years. I did go look at the 4018 some years back, but that was before the project. And it's got the jacket on it, it's got asbestos on it still, which means it's got moisture sitting up against that barrel. I grew up in Denver, well aware of the 4005. I know all about the 4004. That locomotive's been flooded twice. I'm 6'2". The drivers on that engine were underwater. The water was almost to the running board. So it'd been flooded a few times. Not that you couldn't restore it, not that you couldn't fix all of the things that I've talked about in terms of the rust, but what happens is that you make it that much bigger and that much more expensive. And when you start talking about the pressure vessel, the shell thickness on those barrel courses is enormously thick. And again, not that we couldn't find somebody to roll that plate for us and form it, figure out how we're going to rivet those big giant things together. Well, why not just find one that's in its best shape as we can? And the 4014 was the only one it's the only one I asked for. I didn't go look here, I didn't go look there, I didn't call this person or call, nothing. I immediately went out to California. And when the vice president that day, I told him when we were talking about whether or not we would be interested, and what a neat mandate that is for a person like us. Hey, would you like to restore a big boy? Nah, our hands, we don't want to do that. Nah, we're too busy. We want to take our vacation this fall. So I tell him, after explaining all the things about the big boy, I'm not trying to make it sound impossible to him, but I want him to communicate to the decision makers, and there was 5 decision makers, that hey, this is what we're going to do, but it's going to cost this much, it's going to take this much time, and in order to do that, we got to fix the steam shop, we're going to need to upgrade that, we got to fix this, we got to buy new ties, the track is in terrible condition, the turntable doesn't work very good, we got to fix all this stuff up. The cars are worn out, we got to fix those, and so it just comes to this huge project. But that's the springboard, that's the jumping off opportunity to bring all this information to light in such a way as to where we can start planning, mapping out. So the next thing he says to me is, go get us a big boy. And I left. I didn't need the elevator. So I immediately, and we were running in 2012, so we had more trips to make, and we had a little bit of time in California. We were going to go to Sacramento, because we crisscrossed the country. We went here, and we backed up, and we went back, and we went this way, then we went out here, then all the way to Sacramento, then all the way, overnighted into Cheyenne, left and kept going, went down to Houston, came back on the BN. We were going all over the place. A bunch of brand new train guys, and we're taking this locomotive all over the country. And I'm like, I gotta go ask him about that 4000. I wanted to get down to see the 4014 and actually talk to him. You know, and I didn't want to call him because I was afraid that it would leak out. Because we wanted to keep it quiet until we know we had a deal. And then once we know we have a deal, well, then we'll make a big public announcement. So trying to keep that news quiet, you know, we did a pretty good job. Several of us on the crew, when we were traveling that winter, or excuse me, that summer, guys, you know, as fun as it is, there's some pretty long days. The guys would be kind of getting tired and starting to drag a little bit, and I would give them this here, you know, 4014. They'd straighten up a little bit, smile. Austin would give me that big old grin, you know, so it was really fun.
Are there public tours?
Oh, yeah.
Of the steam shop in Cheyenne or the restoration?
Yeah, we're offering public tours, and we're working with our partners in Visit Cheyenne and the Cheyenne Depot Museum, and they set up the logistics, and they include part of another tour. But that tour includes a trolley ride over to the steam shop, and we give a 45-minute tour in the main shop and a 45-minute tour in the roundhouse. And we do offer tours, but recognizing that we want to get some work done, so I'm the point of contact for tours. So if anybody, preferably a large group, that way we could work out a Saturday or a Friday afternoon or something like that. Now the tours with Visit Cheyenne will discontinue at the end of this month. So we've got to prepare for the April trip, and then we've got College World Series Frontier Days, and we may have one other trip, but we want to get this big boy done, so we're trying to balance everything. We're trying to balance the opportunities to travel with the steam locomotive with the need for us to get this done. So,
There will still be depot days in May.
yes, yeah, depot days in May. Excuse me, Ira?
Yeah, two quick questions. Any real surprise on the 4014?
Did everybody hear his question? Any surprises on the 4014? Not really.
Good.
Yeah. I mean, if we've been surprised at how good things are. But, you know, that's why we wanted that locomotive. There's some rust and there's some things we got to deal with. The throttle's giving us fits, trying to get that apart. Part of that design is it's got a little enclosure there called an air gap that goes down between the whistle connection and the smoke box shell. And water can get down in there, and of course it did. So we're probably going to have to fabricate all kinds of parts there. But there again, if you are unwilling or unable to fabricate big engine parts, you're not going to be able to run an engine for very long. So we'll just make her all nice again.
Do you have trouble finding foundries and machine shops that handle stuff that big?
The question was, do we have trouble with finding foundries? Well, as of yet, we haven't had to cast anything really big. But we've sourced some pretty good foundries within this tri-state region. There's some pretty good foundries. We got a nice forge company back in Indiana we use on a regular basis. And when you find people that can do good work for you and you get that relationship established, that helps kind of pave the way for other projects. All the spring rigging components, you know, these big spring hangers and all that stuff, the springs, that buckle is forged around there. Those big leaf plates are forged. I mean, it's just specialized work. And in our modern industry today, we've got great capacity in America, but there's certain elements of the steam locomotive that you've really got to be persistent. And you got to make a lot of phone calls. And if it doesn't work out, you know, we got to make it ourselves.
What is the status of 3985?
People always ask that question, the status of 3985. And the status is that it's in the roundhouse awaiting the same level of repair that the 4014 will receive.
So it's not operational?
Correct. Yeah. Yeah, our intention was to operate it in 2011, but just like in 2013 when we started looking at that 844, the more we took it apart, the more problems we found. Same kind of circumstances.
Driver bearings, it says?
No, the drivers are okay. You know, there was a work scope on the drivers, so the running gear isn't in that bad a shape. But the engine's been run an awful lot. So we'll need to that was my intention, was to pull that front engine out just like we've done on the big boy and go through. There's a lot of piping that's been abandoned on the Challenger. It's been replaced with rubber hose. Well, the rubber hose leaks, and now it's just a lot of problems. Mountains of grease and stuff underneath there, and hard to get to it and fix it. Springs that are worn out, wheels that are, you know, it just needs a good rebuilding. Great locomotive, good foundation, it'll run again, but we've got to prioritize what we're doing.
How long will that, you think it'll be till?
I don't have a timeline for that.
Okay.
Once you took the front engine off 4014, how did you get the rest of the locomotive into the shop?
We fabricated a dolly truck. We took a freight car truck and fabricated an arrangement at the same height as that boiler bearing, that big waste bearing plate and that liner. And we connected the two, lifted it up, pulled the engine out, and then rolled that dolly truck, set it down on there, and then we tied it together with that yellow painted drawbar. I don't know if you remember that picture, but it's connected back to the articulation pin casting. There's a hole back there. So it's all tied together. And you just roll it in nice and easy. We're not going to be bebopping down the yard tracks with that, but just enough. It's called a dolly truck. And we did the same thing with the engine unit when it came out, because we have to support it from either end so we can get all the drivers out. So we just have to fabricate all that as we go.
For the drivers on the rear engine, do those after you get the front engine done?
Yeah, we'll take the drivers of the rear engine out fairly soon. and then we'll support that up. Once we pull the drivers out, we'll support that saddle casting and the trailing truck, and then we can start disassembling everything else. Once you get it that disassembled, to that state of disassembly, you really can't move it that much. You got an awful lot of weight resting on those dolly trucks. Now they're heavy enough to take the weight, but the design, the idea is that you've got to get all that stuff out. And you also have to repair what that dolly truck is sitting on. So the time will come when we'll have to make another arrangement and cradle around that, remove the dolly truck so we can fix that liner on that slide plate, and then go through and do what we need to do there. Same thing on the tail piece for the trailing truck. We got to take that apart. We got to take the equalizers out. We need to pull all that out. It's in, just looking at it, it's in good shape. You know, you look at the Challenger, you look at the 844 engines that have been running as long as they have, you have to take those parts apart. You just can't run them for 30 years without taking something out, fixing it, finding out what's wrong with it. What's happening on the inside could be really bad. So that's got to come apart. All right, well, for those of you that aren't really technical, thank you for bearing with the technical